Hello and welcome back to another LeetCode video. We're looking at easy problems today. And this one is LeetCode 3483, unique 3-digit even numbers. I have not tried this problem myself. In fact, I picked it from the problems that I haven't solved yet. And yeah, so if you've watched any of my other videos, the drill is that we will use LeetCode problems to practice interviews. And by that, I mean practice going through a problem and solving it and explaining what we do while we do it. So it's mostly focused on communications, and I'm practicing clear explanations and all of that good stuff, finding a solution before I write a line of code, going through the examples, even though it might seem a little bit daunting with easy problems, but it's really about practicing the process and not just solving the problem. Because that's what you're going to be evaluated on in a coding interview. So let's see. So we are given an array of digits called digits. Very nice. Our task is to determine if the number of digits, if the number of distinct 3-digit even numbers that can be formed using these digits. Wait, your task is to determine the number of distinct 3-digit even numbers that can be formed using these digits. Note, each copy of a digit can only be used once per number, and there may not be leading zero. Cool. Constraints? Well, okay, so we have at least 3 digits, and all digits are in the range from 0 to 9. All right, let's look at an example to understand it a little bit better. Sometimes it can be difficult from a purely textual description to understand what's going on. So you would ask your interviewer for an example, and then you would walk through it and make sure that, okay, do I understand this correctly? Yes, no, yes, okay, okay, cool. All right, so let's do that. So we have the input is 1, 2, 3, 4, and the output is 12. But why? Well, the 12 distinct 3-digit even numbers that can be formed are 1, 2, 4, 1, 3, 2. Okay, so we just pick digits, and the last digit just has to be an even number. That what that means? Because that's what's true for all of these. Note that 2, 2, 2 cannot be formed because there's only one copy of the digit 2. Okay, what if we have 2 copies of a digit? Let's see. So how many distinct even numbers can we form now? So I guess, well, I would say 20, 22, 222, 202. But that's not true. The only, it has to be a 3-digit number, sorry. The only 3-digit even number that can be formed is 202 and 220. Oh, I see. The digit 2 can be used twice because it appears twice in the array. Cool, I see. I see now. Okay, so yeah, so it has to be at least 3 digits. No, wait, at least or exactly? Distinct 3-digit even numbers. Okay, has to be 3. And the numbers that we form, they have to be distinct. Next example. So we have 3 even numbers, and well, we can only form, because they're all the same, we can only come up with one way to build an even number. Then we have a bunch of odd numbers, and so that means we can't really form any even 3-digit number with that. Okay, interesting. So I don't see the solution right away, but I guess also always makes me sweat a little bit because it's an easy problem and I don't see the solution. What's going on? But that's normal. And if it doesn't occur in easy problems, it will occur later in medium or hard problems as well. So, all right. So what can we do? Well, I suppose what we can do is, well, the first smart thing to do would probably be to say, okay, let's pick the last digit, right? So if we knew, all the different digits that we had and how many we have, we could, yeah, we would know how many times we can pick each digit, but we can only pick each digit for each position in our 3-digit thing once, if that makes sense. So if we place a 2 in the last number, we cannot choose the other 2 to place it there. That's not going to lead us automatically to a different arrangement of digits, right? So, because the numbers themselves need to be distinct in the end. So yeah, I think we should iterate over all of the possible even digits that we have. And then it doesn't matter what digits we pick. We can then pick odd or even digits after that. So here, so here all the even digits we have are 2 and 4. So 4 could be picked as the last digit and 4. And then what comes before that doesn't really matter. It could be a combination of anything what we have left. So I would probably suggest an approach where we first create like a histogram or a count of how many digits of each kind we have. Then for the initialization, I would look for iterating over all of the even digits that we have and placing them there and decreasing the count as we put a placement. And then maybe with the recursive helper function, we then pick another digit. I think that is what we could do. And since we only have 10 digits, yeah, since we only have 10 digits, we can just iterate over the 10 digits, check whether it exists in the digits that we have received, and then put the placement there. So I would do a recursive approach. Of course, the recursion depth is only going to be 3 because we only going to pick 3 digits. And in the recursive function, I'll make sure that we don't pick the same digit twice for the same place, except if this selection was a different. But yeah, so that would be my approach, and everything will be constant space and time because we're only going to build 3-digit numbers, and we only have 3 digits to choose, and we only have 10 digits to pick from maximum. So everything is going to be constant space and time, right? And if we had to pick more digits, if n was not 3 but n was n, so if n is length of digits, or actually that's not quite right, because length of digits, that is also constrained. Yeah, so let's run just with the constant space and time for now. Why not? They didn't try to make it a little bit more difficult, then why should we do that, right? So yeah, first would be for me to count how many digits I have of each kind. So I'd probably create like a hash map, maybe call this counter, and we initialize it like so, and then we iterate over all of the digits, and we will say, well, we could also initialize our counter, right? All zeros, and we're going to iterate from 0 to 9, and we're just going to add initialize with count 0. Then we just say counter at plus equals 1. So that's the initialization. And now we have to have a little helper function, and that tells us which digits we have to choose, right? So, right, and let's say, well, our base case is going to be if I is larger than 3, means we have identified one way to pick 3 digits, and we're just going to return our count. And otherwise, we're going to return, now comes the recursion part, right? So what do we have to do? Well, we have to check if I is equal to 0. That's going to be where we have to find an even digit, right? So we're going to iterate over all of the digits for digit in range 10 if modulo 2 is 0. So if it's an even number, we could also just say, with step size 2, that's the same thing. Yeah, let's do that. So it's guaranteed that D is now an even number. Well, what we'll do is, if counter at D is larger than 0, that means we can actually pick that number. right? So that's cool. And otherwise we need to continue. Or equals 0, continue. Otherwise we can actually pick that number and we decrement our counter. That means we now have one less of that digits available for selection next. And we now do our recursive call. And we're going to add the result that it returns, helper. And we're going to say I plus 1. Now, after we return the call, we actually have to increment the count again to restore it. Right? Because when we continue to loop, so we're basically now picking the digit D for the start of our string from the end, of course, because it's the last digit. And but when we pick another even digit, an even digit that we picked previously has to be put back so that we can use that digit later when we expand our string. I understand this was a little bit complicated, but if you think about it, you'll see that I'm right. Right, so maybe, cool. So that is the base case, and not the base case, but the case where we need to pick an even number. Now comes well, the other case, and now we are free to choose any number that we want. Right, so we can just range with all the digits over all possible digits, and we can choose any of them. So we don't have to, do this step size. And I realize we have a lot of redundancy now, so why don't we simplify that a little bit? So we'll just do like so, and we will have a little check here. If I is equal to 0 and D modulo 2 is equal to 1, we're going to skip over the odd number. Right. And yeah. And I think that would be the entire thing. So if we picked 3 numbers, that means at first I is going to be 0, then I is going to be 1, and then I is going to be 2. When we enter the helper function with 1, that means we already picked 1. When we enter the helper function with I is equal to, that means we picked 2 values. Now if we enter the helper function with value 3, that means we're done. So we have to change this. If I is larger or equal than 3, means we're not going to pick another digit. We're done. We already built a 3-digit number that ends in an even number. Cool. And yeah, and now all we have to do is return whatever the helper gives us back, and we start picking the number at index 0. So well, I'm kind of curious of whether this works now. So let's actually run a little test, see if it passes the test cases. Okay, so we now have an example where it doesn't work. Aha, so we haven't considered the edge case of zeros, right? Because if I is equal to 2, so when we're picking the rightmost digit, we can't choose a 0. So we have to add a special case here. So that is if I is equal to 2 and D is equal to 0, can't pick it. We have to skip over that. Yes, so I missed that edge case because we cannot have leading zeros. So this. Now the test cases pass. Okay, cool. Okay, now the big reveal of whether it solves the problem, and it does, and it's nice and fun. Cool. Yeah, so that solves this problem. It's interesting that this was an easy one. So that probably means that there's a much simpler solution than the one that I came up with. I kind of picked one that you typically use for medium problems when you build combinations of things. And but yeah, doesn't matter.